Hello everyone. Today let's solve the problem number 435, non-overlapping intervals. So what the question states here, we are given a list of intervals. The goal is to remove the minimum number of intervals, right? So here we have been clearly given the intervals right here. So the goal is to remove the minimum number of intervals so that remaining intervals are non-overlapping. So we have to remove the overlapping intervals, right? So the goal the goal is to remove the minimum number of intervals so that remaining intervals are non-overlapping. So two intervals a comma b and b comma c that touch a point are considered non-overlapping. Means only the intervals a comma b and b comma c that touch a point are considered non-overlapping, right? So they have given clearly here, right? So let's come to the first example. So here in this case we have the intervals 1 comma 2, 2 comma 3, 3 comma 4 and 1 comma 3 we have here, right? So here we can clearly see 1 comma this one 1 comma 2 and 1 comma 3, this one we can remove, right? So this one we can remove. In the question they have clearly mentioned a comma b and b comma c that touch a point are considered non-overlapping. See here, a comma b and b comma c touch here because we have the same number 1 comma 2, 2 comma 3. This, let's, if we consider this one x and y coordinates for every interval, so y coordinate of the first interval and the x coordinate of the second interval match, right? So in this case it is said to be non-overlapping. We cannot consider this one. 2 comma 3 and 3 comma 4 we have here in this case. So 3, same thing, the y coordinate of the second interval and the x coordinate of the first interval, third interval basically match. So this is also non-overlapping. But in this case we have 3 comma 4 and 1 comma 3. Here y coordinate of the third interval and the x coordinate of the fourth interval doesn't match. Basically in this case it is said to be overlapping and we can remove this one, right? 1 comma 3, we can remove the 1 comma 3. So other things will remain as it is. So we have removed one interval, so the count we need to return, this count we need to return as output. So in this case we have got the output 1, right? So here 1 comma 3 can be removed and the rest of the intervals are non-overlapping. That's what they have given in the explanation. That's what I tried to explain right here. So let's come to the second part here. See, we have 1 comma 2, 1 comma 2, 1 comma 2, same thing, right? So we need to remove 2 1 comma 2 to make the rest of the intervals non-overlapping here in this case, because here all the intervals are same. We need to remove other two, means this 1 comma 2 and this 1 comma 2. See here, y coordinate of the this one first interval and the x coordinate of the second interval doesn't match. Y coordinate, this one is having 2 and this one is having 1, so it doesn't match. Same goes with the next one as well. See, y coordinate of the second interval is 2 and x coordinate of the third interval is 1, and they are not same, right? So we will be removing the second one and third one, and so the count here is 2. We are removing 2 intervals, right? So that count we need to return. In this case we have got 2. Let's move on with the third one here. In this case we have intervals 1 comma 2 and 2 comma 3. See, the y coordinate of the first interval and the x coordinate of the second interval is same, right? So we cannot remove. So this is non-overlapping. So we cannot remove any interval here. In this case we have to return 0. That's what they have given us output here, right? So explanation they have clearly given here. You don't need to remove any of the intervals since they are already non-overlapping, right? So they have given a wonderful examples just for the sake of understanding, right? So I hope this is clear. I hope the question is completely clear and what we need to do is completely clear as well, right? First let's discuss the approach, followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially let's discuss the approach. So the first thing that we need to keep in mind here is we will be going with a greedy plus sorting, or we are going with a greedy plus sorting approach, right? So I have considered the same first example that they have given in the question. So here we have 1 2 2 3 3 4 and 1 3. We have already discussed this one. Y coordinate of the first interval and the x coordinate of the second interval are same here in this case, so they are non-overlapping. Next let's go to the second interval here. Y coordinate of the second interval and the x coordinate of the this one third interval are same again, so they are non-overlapping. Let's consider the same for the next one. So y coordinate of the second interval and the x coordinate of the y coordinate of the third interval and the x coordinate of the fourth interval varies here. They are distinct, right? 4 and 1 values are distinct. So we can remove one interval, nothing but 1 comma 3 here. This can, so we need to return the count of how many such intervals can be removed. Here in this case 1, so we are returning 1 as output. So I hope this is clear. We have already discussed this one, right? So let's discuss the step-by-step execution here. So intervals we have here as 1 comma 2, 2 comma 3, 3 comma 4 and 1 comma 3. So it's the same one, the first one we are considering here. First what we will do, we will sort by end time. So after sorting by the end, the array becomes like this. So sorting means we are sorting in the ascending order by end time, right? Here I am clearly saying after sorting by end means end time. So here in this case 1 comma 2, 1 comma 3, 2 comma 3 and 3 comma 4. We are sorting this one in the ascending order. So this comes first, this comes second, this comes third and this comma 4. This comes fourth. This is fine. So the next step here is, let's move on with the second edge case here. Start with the first interval's end time. Means we have previous and 2. So we have previous and 2, this one we are speaking of, right? So we are starting with the first interval's end time 1 comma 2. We have previous and is 2. So we will iterate through the remaining. So we have next, the second one is we have 1 comma 3, right? Start equals 1, which is less than previous and 2. So this overlap, basically we will increment the count to 1. Means after sorting here in this case we have 1 comma 2 and 1 comma 3. In this case previous end is 2 and this one start is 1, right? Start is 1, previous end is 2. Both differs here, the number differ here. In this case we will increment the count to 1. In this case we will increment the count to 1, right? Let's move on with the next case here. This one 2 comma 3. So start is 2, previous end is also 2 here. Same thing. Let me come here. This one 2 comma what we have now, 1 comma 2 and 1 comma 3. So we can remove 1 comma 3, right? Here next we will go with this one and this one, 1 comma 2 and 2 comma 3, right? So in this case just give me a second here. Yeah, 1 comma 2 and 2 comma 3. So now start is 2, previous start here is we are considering 1 comma 2 and 2 comma 3. So start here, this one we will consider as start, this one we will consider as previous end. So start is 2, previous end is also 2 here in this case, right? So these both matches, so count remains same here. In this case we are not incrementing count remains 1 itself here in this case. This is fine. So overlap, update, so here in this case no overlap, so we'll update the previous end to 3, right? So actually this has to be no overlap, right? This is fine. So let's move on with the final one here, 3 comma 4. Start is 3 and previous end is also 3. These two we will consider this one. Now 1 comma 2 and 2 comma 3 we considered, we didn't remove anything, right? So count will keep the same thing. We are going with this one, 2 comma 3 and 3 comma 4. 2 comma 3 and 3 comma 4. Start is this one, start is 3 and previous end is also 3. 3 equals 3 in this case, right? So let me come here. Start is 3 and previous end equals 3 and it is greater than or equal to 3 itself, right? So no overlap here. We'll update the previous end to 4. Previously we updated the previous end to 3 and here in this case we will update the previous end to 4. So total removed interval is 1, only this one, right? So I'll just come here, we removed only this one, 1 comma 3, right? So because the start and this one previous end were not same, the values were not same, so we were able to remove only one interval. So that we need to return as output, we return the same thing, 1. So the final output that we got here is 1, which is equivalent to the output that they have given for the first one in the question, the first example in the question. In this case also we have got 1. So the approach works absolutely correct in this case. Now as we are completely familiar with the approach, let's discuss the edge cases one by one. The first edge case is for the all intervals overlap. When I say all intervals overlap, we must remove 2, right? So to keep one non-overlapping. So here in this case 1 comma 2, 1 comma 2, 1 comma 2 we have. First we will consider these two. So here this will be previous and this will be start, basically this will be start. So start is not equal to previous and we will remove this one. Same when we compare this one, this will be previous and this will be start, right? So again start is not this one equivalent to the previous end. Basically we will remove this one as well as we'll remove this one, and only this one remains, right, in this case. So we are removing two intervals, so the output is 2 here in this case. Let's move on with the second edge case here. No overlap at all. So here in this case 1 comma 2, 2 comma 3, 3 comma 4 we have. So 2 matches with 2, again 3 matches with 3. So we cannot rule, there are no overlapping intervals at all. In this case we have to return output this one 0. We have already discussed this one in the examples, right? I think third example, if I remember correctly, second or the third example, the same thing. So let's move on with the third edge case here. Only one interval, we have 1 comma 100 here in this case. So we don't have the other intervals at all, so the output, we cannot remove anything, so the output will be 0. So let's move on with the fourth edge case here. Only one interval, so here minus 50,000 to minus 40,000 and 40,000 to 50,000. So here we don't have the same value, right? So this is minus 50,000 and this is next one is plus 40,000. So both differs, right? So the output that we need to return here is 0 in this case, right? So these are the four edge cases that we need to consider here. So the first edge case is for the all intervals overlap, the second edge case is for no overlap at all, the third edge case is for only one interval, and the fourth edge case is for only this one. This is not for the only one interval. Basically large negative and positive boundaries, this is for large values. I'll just write here large negative and positive values. Basically I'll just give positive and negative values. This is not for only one interval, we have two intervals here, right? So this is for large values, positive and negative values. This is fine. So these are the four edge cases that we need to consider, right? So now we are completely familiar with the edge cases as well as the approach. As we are completely familiar with the edge case and approach, we are good to write the code. Let's start writing the code. So here the first step is we are going with the edge case. If no intervals, then we have to return 0. We have already discussed this one while we discuss the edge cases, right? So if no intervals exist, then we have to return 0. So I'll just write the simple if condition here. If the length of the intervals is 0, then what we will do, we will return 0 in this case. This is fine. So the next edge case here, so next step here is we have to sort the intervals by end time. Means we are going with a greedy approach, right? So we are sorting the intervals by end time, nothing but greedy approach here. So I'll just go with here arrays dot sort this one intervals comma this one a comma b. So we will go with, in this case, integer dot compare of a of 1 comma b of 1. This is fine. So the next step here is we will count, basically we have to count the non-overlapping intervals that we need to remove, right? So let me initialize count to 0 first, and also we need to keep track of the end of the previous non-overlapping interval as well. So nothing but previous end, right? So in simple term, we have already seen this one count. We have to keep the count and we have to go with the previous end as well. So here in this case, I'll just go with capital E previous end. So let me initialize this one to intervals of 0, 1. This is fine. So the next step is we have to iterate through each interval, right? So I'll just go with here. We have to traverse through each interval, right? So in the array, so I'll just go with I equals 1 here, I less than intervals dot length. So this one I plus. This is fine. So within the for loop, what we will do, if the overlap is detected, then we need to remove 1. Means if the previous end is same as the start, then we will not remove. If it is same, then we will not remove. If it is not same, then we will remove that one. Means we will increment the count. We have already considered count here, right? This one count. So that one we need to articulate the same thing in the form of code. Let me write the simple if condition here. If intervals of I this one 0, if it is less than previous end, here in this case what we will do, we will increment the count. So this I'll just go with count plus. This is fine. So the next step here is else what we will do, if it is no overlap, if there is no overlap, means then what we will do, we will update the previous end to current intervals end. So I can just write here on this way. So we have already discussed this one. Previous end equals intervals of I. This will be 1, right? So this is fine. So the final step here is we have to return the total intervals that we need to remove, nothing but in this case count, right? So we have considered the count variable to count the number of intervals that we need to remove. So here something I did a mistake. So here, just give me a second. So here, what mistake I have done, I don't know. Just give me a second here. Why this happened here? So let me do one thing. Let me run the code. Let's see if I have done any mistake. So in the line number 3, we have the error. Parenthesis expected. Oh, here, yeah. Just let me give the parenthesis here. Line number 20, we have error class interface enum or record expected. So I'll just remove this one. So let me hit the run button again. So again, line number 3, illegal start of the expression. So this one is within. So let me give parenthesis here. I hope this works. Let's see. So yeah, now we can clearly see the sample test cases are getting passed. So let me hit the submit button quickly. I hope this works for all the test cases as well. Let's see. So you can clearly see here all the test cases are getting passed. Means the code works absolutely correct on this case, right? So let's quickly discuss the complexities for the code that we have written. So in this case, the approach that we went with here is greedy plus sorting by end time. We know this one, nothing but greedy plus sorting, right? So overall time complexity here would be big of n log n. So I'll just give here big of n log n. So here in this case, sorting is the dominant factor. Sorting takes big of n log n, the time complexity, and we are looping through the intervals, right? I'm speaking of the line number 11, basically this one I'm speaking of. We are looping through the each interval here. So we are looping through the intervals which takes big of n, and sorting takes big of n log n, and sorting is the dominant factor here. So overall time complexity that we need to consider here as big of n log n. This is fine. Let's move on with the space complexity here. Space complexity, here we are only sorting in place, right? We are only sorting in place, and certain constant extra variables are used. So overall space complexity would be only big of n. We are just making use of certain variables here, right? It may be count and previous n, right? These are the variables we are making use of. Only 2 variables is being used, right? So only constant extra variables are used here. No extra space is being used, right? So overall space complexity remains big of 1. So the time complexity for the code that we have written is big of n log n, and the space complexity is big of 1 for the code that we have written, right? I hope the complexities are completely clear, and I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.